So I'm going to continue where we left off last time with the delays removed here, showing the 50% duty cycle for bit 6 here. And what I'm going to try and do is actually come up with a way to have this button press be more accurate. And have this even running at the high speed that it's running at without the delays to make this work as a push on, push off. So since we're making this change, I'm actually just going to delete some of this. I'm going to delete the delays, I'm going to delete the binary, delete all this, and I'm also going to take this code and pull it down here. So and what I'm going to do is actually, what I'm going to do with this formally blinking LED is I'm actually going to say that if the button is pressed, we are going to illuminate it. So this code right here, this bit 6 set to 1, illuminates an LED. Illuminates that LED number 3. So we're just going to set this to 1 anytime the button is pressed. So this is going to act as a LED on when button pressed. Okay, so that's fairly easy to do. Basically, all you have to do is check the button state. You don't have to track whether or not it should be on or anything like that. We're going to leave that to be the more complicated one for LED 1. So this is LED 3. LED 2 is just still on, so that's fine. We'll just, well, sure, why not? Let's do something with LED 2 as well. So let's say that LED 2 we're going to set on, except for when the button is pressed, and we're going to turn it off. So, I don't know, it doesn't really matter. I mean, we just have a few LEDs to play with here. We already know that they essentially work, so it's really just sort of coming up with something interesting to do to kind of try out and get more familiar with the code. So I'm just going to leave my note here. This is LED 2 and this is LED 3. So LED 3 was going to be off, LED 2 is going to be on. When the button is pressed, they swap. So they're going to be separate. So essentially, kind of what we're trying to program here for LED number 1 is really some sort of a latch. It's really some sort of a latch. So the way we do that is, let's add another variable here to say last state. That's what we're going to call this, is last state is 0. So we want last state to be the same as, defined in a similar way as should be on. So last state is 0. So what we're going to do here is we're going to say, so what we want to do is we want to check to see if last state All right, so what I'm actually going to do is, I just changed the code here. So what I'm going to do is on this if here, so this is if it's down, so this is, you can also put an else here and say this is what would execute if the button was up. So what I'm going to set here is actually was down. So it's set to 0, and I'm going to set it to 1 in this case. And that is all I'm going to do right here. So it's going to say, yes, this button was pushed. And then what's going to happen is it's going to run this code when the button is no longer pushed. So the first thing I'm going to check for is essentially this line. It's going to be was down equals 1. The reason is because we're only setting was down equal to 1 right here. So it's going to be set over and over and over again while the button is being held down. And then once the button is released, the next time this cycles through, which is an insignificant amount of time, really, between, the time between the last time it was run through versus when you release your finger. You could think of this as the HTML example of on mouse up or something like that, because there's a down click and then an up click release when a link, and actually most of the links are actually navigated in HTML, not when you push the button down, but actually when you release it, when you click up. So you can actually click down on a link and maybe drag somewhere else, and the link won't actually navigate a lot of times. So it's a fairly common way of interacting with things. For actually that exact reason is that mouses have the same exact issue as a button like this would, is that if you really did is down on a mouse, it would signal many times. It would signal for every millisecond or less, unisecond or something like that, that it was down for every cycle. So we're going to check to see if is down is equal to 1. If it is, then we're going to look at this code. So it's the exact same code. It just says, should it be down? If it should be down, then toggle it, and if it shouldn't be down, then toggle it to 1. And then what we're going to do is, in this very last end piece, we're going to say is down equals, or was down equals to 0. So what that does is it prevents this loop from running next time. So, and then should be on, we can just leave right here. Now we don't actually need to. We can actually move it to right here, because we only need to be turning this on and off when there was a change. So I would prefer to put that as the very last statement. It really doesn't matter at all, but that's just my way that I would want to do it, just for cleanliness. So really, okay, so what we have right here is LED2 is going to be off, or excuse me, I'm going to change this. LED2 is going to be on. LED2 is going to be on. LED3 is going to be off. This is all formatted correctly. This should all actually be indented as well. Clean up my code here. It makes me look like I'm missing something. Everyone has their own preferences as far as where they do. Yeah, that's what it is. This is for, oh, this isn't indented enough either. That's why. Weird. All right, now I got things more or less lined up. Yeah, I am so used to Eclipse and its code formatting functionalities that I kind of gloss over the fact of when you have to manually format code. Really get used to very used to the auto formatting. So, and this honestly, MPLab may have that. I just haven't found it yet. So, all right. So LED2. I'm gonna move this code first. We got everything in the right order. Okay. LED2 is going to be on. LED3 is going to be off. When you push the button down, LED2 goes off. LED3 goes on, and we set was down to equal to 1. Now, when the button is released, so button up, we say, was it down? If it was, then we run the logic to toggle should be on, which is going to start as off, and then we set should be on to LED1. And then we unset was down so that this code doesn't run again until the button is pressed again. So let's go ahead and build this, see if there's any issues there. Pull this up to see. I wouldn't guess that there would be any issues just because we haven't done any huge changes here. Okay, that's good. So let's go ahead and program the device. And then let's take a look and see how it works.
Alrighty, so what do we have here? We have LED2 is on, LED1 is off, and LED3 is off. So let's push the button here and see what happens. So what we're expecting, yep, not quite. So what we have here, LED1 is indeed toggling on and off, so that toggle code is working perfectly fine. LED3 though, is coming on when we push down, but LED 2 is not coming off. So I'm guessing that there is some little bug in the code. Let's take a look at that and reprogram.
Alright, so there was a little bug there as far as LED 2 never not being illuminated. So let's scroll this down, see if we can figure out what the issue is. LED 2 sleep bits 4 should be on. LED excuse me, launch E, not late. 4. Oh, okay. So here is the deal. So this comes back to duty cycle again, and the reason is that if we can shrink this down again, I did sort of see something like that, but since it was affecting both LEDs, it wasn't as clear. So essentially what was happening was LED number 2 was at full strength, and when you press the button, it goes to 50%, and LED 3 was at 0, and when you press the button, it goes to 50%. So you've got 1 at 100 going to 50 and 1 at 0 going to 50. It's not clear really what's happening there. So really what's going on is that we need this code to be here. The reason is, so we have the whole reason that we have to use was down right here is because if you don't, this code is going to execute every time. So, but in this case, we want it to execute every time. So we want it to either be setting it at 0 or setting it at 1, not setting it at 0, setting it at 1 very quickly, alternating it. So really, this is the structure we want as opposed to it being up here above. So let's go ahead and build this code, program the device, and take a look and see what it looks like.
Alright, we're back here, and now we've got the newly loaded program in. Already looking better because we only have, well, no, I guess now this is about what it looked like before, but now, I already tested it, I cheated, so when I push down, you'll see that LED 1 is not illuminated, but LED 3 is. Now when I let my finger up, it will flip back to LED 1 now being toggled to on, and LED 2 illuminated. So LED 3 illuminated, and then back to LED 2 illuminated. So you can see that it has the exact effect that we were looking for. And you can also see, because of the brightness here, that we have these running at 100% duty cycle, so they are definitely running full voltage. So again, is this a useful thing? Probably not really, but it's something that you can get started on as far as playing around and you know, getting used to what you can do with these microcontrollers. So, you know, that's really kind of the goal of what we're doing here, is just experimentation and, you know, like I said, using some switches and LEDs and seeing what we can do.